Hi, everyone. Thank you for attending. We're just going to give it about a minute or so for a few more people to trickle in, and then we'll get started. Excellent. So I think we've got a pretty good group that's in right now, and I'm sure a few more people will come through as we carry on. So just a couple of hygiene points before we start today. So um, one, I guess, by introduction. So thanks for joining us today. I'm Will Lytle. I'm our COO here at Plandek. As we go through today's presentation, please do feel free to ask questions. There's a Q&A box. You should find it, I think, towards the bottom of your screen, depending on how you've got your screen set up. You can click on that and type it in. I will be in full flow through a lot of the conversation, so I'll try to pick out some of them. But obviously, once we get towards the end, we've got an hour today. I don't think the presentation will take an hour, so there'll be plenty of time for Q&A for us to go through some of the questions that folks have asked today. We'll also be launching a poll that will happen probably about 5 or 10 minutes into the webinar today. So yeah, if you get a chance, would love for you to fill it out, get some feedback, straight away in terms of where folks are in their journeys, and that can help sort of enrich in the kind of experience today and kind of focus areas that we talk about. So without any further ado, I will share my screen and we'll get started. Excellent. Okay, great. So again, thank you for joining today. As many of you well know, AI and the drive to AI-augmented software engineering is topical within most organizations. Many different companies are in different states, but it's going to be our main focus today. And really the kind of origin, the background of this framework through loads of conversations with our customers and loads of experience, ourselves internally here at Plandek as we're on our own journey, is really about this idea around, okay, you buy a bunch of licenses and there's a huge expectation that once you buy those licenses and people start using AI tools, suddenly you can achieve these 10x productivity numbers. And the reality is it's not that simple. And what we're going to cover today is a lot of the rationale of why it's not that simple, and also a framework to help you on your journey, or one that we hope will help you on your journey. It's been very much, as I mentioned, based in deep conversations we've had with a number of our clients at different stages of the journey. So it's sort of empirical based, as well as a little bit of IP that we've added from our own perspective. So as we think about the sorry. Sorry, computer was acting up there for a second. So we think about the transition and really kind of transformative impact that's had it. There's a lot of semblances to the gold rush of 1849. There's huge claims around, what the outcomes are that different organizations are achieving. We've done this in this date, and this has allowed us to do this, and there's a lot of hype around it. There's a lot of marketing around it. But without a shadow of a doubt, from what we're seeing, most organizations, whilst there will be success stories, are really struggling to scale that. Okay. But 90% of our clients today have rolled out Gen AI tools within their organizations, within particularly their software engineering organizations. Gartner predicts that that's going to extend out to about 90% in the next couple of years across all enterprise engineers. So I appreciate, within our customer base, we certainly have a certain segment of technology businesses out there, but that should really touch all businesses by quite a significant amount over the next couple of years. Over the last couple of months, we've had a number of different sessions that we've run and surveys that we've run with different technology leaders. And one of the things that's really shown through is, whilst 90% of folks are on that journey, very, very few of them have reached a point where AI is really being adopted and driven across their organization. Only about 15% of the CTOs and the CIOs that we've spoken to have said that they've reached 90% adoption. And that's kind of basic level of adoption as well. It's not even that we are fully agentic and we've transformed the SDLC and our operating model within technology. It's just that in different ways, whether it's in asking or assistance or agentic mode, teams are starting to use these tools day to day, week to week as part of fundamentally how they work. And where it really focuses the attention in an interesting way, whilst technology is going through different transformational journeys, I think this is one of the first ones where technology leaders are not only being asked to transform other parts of the business in terms of how they use AI and technology, but also how they transform their own engineering and delivery functions themselves, which presents some pretty unique challenges and some pretty unique opportunities. So, as we mentioned, there's been a load of hype around the impact that AI can have and will have. And we saw last year, in fact, probably 2024 now, because we're in 2026, GitHub and Microsoft in particular were pushing quite heavily how, the studies that they had run had shown that developers were able to complete tasks 20 to 55% faster, that you're going to have more pull requests and more successful builds. There's measurable time savings on specific tasks. There's been a lot of hype within the marketing materials that's been pushed out to that. The reality is a lot more complex. And, there was a study last year, I don't know if folks have read it, by MIT, where about 19% of experienced developers, the developers took about 19% longer in text execution than they thought they would be, despite the fact that they were believing they were about 20%. So there's a really big perception gap in terms of what the expectation is, both within engineering and outside of engineering, versus what that reality is. And we're going to really dig into that a bit today as we go through it. One of the big challenges in the way that we think about a lot of our conversation today will evolve around this is around the system level constraints that, yes, we do see individual gains. Task execution, particularly well-defined task execution, can increase and improve significantly. But ultimately, AI doesn't fix a team. It amplifies what's already there, right? So strong teams that are using AI are using it to become better and more efficient. Struggling teams find that AI is really only highlighting and intensifying some of their existing problems. There's a hand raise, which I was not expecting. So Guillaume, if you can, there's a Q&A box. So if you have any questions, feel free to type it in there, and I'll definitely get to it as we carry along. So today's conversation is going to focus on kind of three areas. Number one is, what is productivity in software engineering, and how do we start to think about how productivity is measured, and thereby how AI is ultimately able to influence that and optimize how we're focusing and how that focus translates into business outcomes. Part two is we're going to go through the RACER framework. So as I mentioned a little bit earlier, we've launched this new framework really as a way of helping organizations think about, how do I go from buying a bunch of licenses to actually showing some meaningful business results. So a lot of our focus today is going to be on that. And then we'll finish up with a couple of next steps, some practical next steps for you to take away, things that you can do this week, this month, and next quarter as you're starting to think about how we do this. So let's talk a little bit about productivity. And I think this is, appreciate that some people might cringe a little bit at what I'm about to show you, but, ultimately, the success of any business in reality comes down to this equation, this simple balance here. And it's between the revenues that we're able to generate against the cost that we invest to generate that revenues. And product development is really no different, right? When we think about complex enterprises and complex businesses today that have multiple products, what you really want to do is understand, which of those products are really successful, hitting the market, generating buzz, capturing new business, retaining existing business, are able to generate the most amount of revenue for really the least amount that we can invest into it. And so when we think about what comes down to engineering, how we spend our time really matters, because if we're spending our time building a lot of features and new functionality that doesn't translate to happier customers, new customers that stay longer with you, it's very difficult to justify that cost is being effectively spent within the business. So putting it in another way, we start to think about the capacity challenge, and most organizations will recognize this, I think, quite intimately. Every engineering team starts with a total capacity of 100%. You have all the time in front of you, and you're excited and you're ready to go, and you're looking at what to do. And whether you're working in a regulatory environment or not, there's going to be part of your capacity that's going to be reserved for, could be technical debt, could be compliance work, could be regulatory work. Part of that is reserved. And so you kind of package that away and kind of say, okay, well, we know that 20, 30% of our capacity is going to be focused on these things. The next is really where things start to unwind a little bit. And that's around the unplanned work and your inefficiencies. So yes, we're building software. And yes, we expect to find a number of bugs and defects along the way. And we know that there's some capacity that we're going to have to focus on doing that. But where things start to spiral out of control and you have more issues than are expected, or more issues that are sitting in the backlog that are taking longer for the teams to be able to address, and therefore are more costly down the road, those in combination with workflow inefficiencies, how we work, are really the two biggest culprits to the consumption. And the reality is what we actually have, right? The actual capacity that we have to focus teams on delivering real value for our business, features that are really going to drive the business, is a result of those upstream commitments and inefficiencies, right? So whether or not we stayed within the 20% that we reserve for technical debt and compliance and regulatory work, or did that slip to 30%? Did we stay within the 20% capacity that we reserve for working through defects and so on? Or did we find ourselves actually up near 40% when you combine those with inefficiencies? The result of that is what you have for the value. So essential work is not something you can really move the needle on. Obviously, you can determine how much you want to focus on technical debt this quarter. But at the end of the day, it's a sort of fixed level of capacity. Where teams really have the opportunity is thinking about how do we manage quality issues and workflow efficiencies to have the highest impact on capacity, right? And once we can actually minimize the unplanned work and the efficiencies, that's what enables us to drive that overall capacity to focus on delivering more value for our customers, which is ultimately what's going to translate into the things that matter most for our business. So how do we then start to think about this, Oregon? So we're about to release our new 2026 benchmarks, and I'll give folks a sneak peek on these today. But they very much, the 4 pillars of productivity that we developed last year and are iterating again this year, really focus on what we think are the kind of 4 key pillars of understanding productivity within software engineering, right? So number one, it really comes down to focus. Are we focusing our attention and working on the things that matter most for our business? What proportion of our time capacity are we able to focus on things that are going to actually deliver value for our business? What proportion of our time is focused on support and maintenance, right? And how do we compare broadly across different product areas and different teams to be able to understand, ultimately what that allocation is, right? Speed, not a massive amount has changed here, but how efficiently and how do we achieve a high flow state? So measuring things like your lead time to value, your cycle time. There's a couple of new things here which people will be learning about shortly around throughput and PR quotients, time to merge PRs, and merges per dev per week. All of these are really key and essential to understanding how are we tightening these feedback loops as efficiently as we can, how are we minimizing friction and ultimately achieving a high flow state within our organization. Predictability, and it doesn't really matter whether you're a Scrum team or maybe velocity volatility will apply to you more if you're a Kanban team, but ultimately, what is the consistency, the reliability with which our teams have to plan and execute, whether it's 2-week increments or monthly fixed versions or whatever kind of structure of plan that you're on. How effectively is that team able to demonstrate that they have good ability to do what they say they're going to do on a consistent basis? That's going to enable us to align with those business plans. And lastly, quality, which, it's not just about building a quality product, but it's about really understanding that how we spend our time, whether it's in a sprint over a course of a month or a course of a quarter, we have decisions to make in terms of, what do we want to focus on in terms of new value delivery versus bugs and defects that we need to resolve. Every defect that we decide to defer for a story that might make absolute sense right now, but the longer that bug sits in your backlog, the more costly it's going to be for a developer to ultimately go back and fix it, right? The context has changed, time has moved on, the code base has changed, and it's going to have a material impact. And that material impact isn't really understood particularly well by a lot of organizations because we're so focused on delivering new features and new stories. But the reality is ultimately you're going to have to pay down that debt. And so the decision that you make to prioritize new features and stories for short-term gain may make sense short-term, but you have to be very conscious about ultimately how is that going to move the needle in terms of your ultimate proportion of time that you can focus on value delivery over the course of a quarter and a year and so on and so forth. So this is kind of encapsulates really what we're thinking about when we think about and talk about productivity and what do you need to measure that really matters in terms of understanding, are we driving the right behaviors that are ultimately going to allow us to optimize the total time that we're spending on delivering value and ultimately be able to optimize that relationship between the revenue and value that we create for our business versus the cost and the investment that goes into our technology functions. So moving ahead, AI's role in the theory of constraints. So we talk a lot about how the AI tools are accelerating coding and testing. What many people on the call today will definitely experience is that they are exposing new bottlenecks in your software delivery process. And whether that is, code reviews are taking longer than is normal because of the changing dynamic and responsibilities of senior developers or other developers in your team in their process, unclear requirements. So, AI doesn't often have the time to work through ambiguity in the same way that a human brain does. And so those are really putting a lot of pressure and challenges on unclear requirements. Manual deployment steps. If you're deploying on an infrequent basis, using AI to accelerate the amount that you can build in that particular time isn't going to help you actually deliver faster. It's just going to actually, if anything, make your releases even that much more risky on the infrequent basis that they're in. Insufficient automation, so testing, poor documentation, whether that's sort of code level documentation or more importantly, policies, component libraries, things that AI needs to actually understand better context and repeatable processes within your organization. So I think the call to arms here really is that the product and engineering leaders should really think about AI adoption, not just as a technology shift or a new tool, but really as an organizational transformation. And that the value that you need to think about unlocking really is based on looking at your engineering practices, your operating model as a whole, and the culture within your organization. And once you tackle those, that will allow you to translate. So the system speed, as the bottom bit says here, is really limited by the biggest net bottleneck that you're going to have in your system. And so today we're going to focus a little bit on that within the context of the RACER framework. So what is RACER? And some of you might have kind of come across the RACER framework so far in our conversations as customers, but really broken down into these 5 different stages. And don't think of these as sequential steps. It's not that you move from R to A. There's a lot of overlap. There's a lot of fluidity between these stages, but they're a very good way of starting to break down and think about where you are. So the first one, of course, is rollout, right? We bought some licenses. We've deployed these tools. Are we using them? Who are we using? We'll cover that more in depth in a little bit. Approach is sort of aligning the right tools for the job. So you have a number of different use cases, whether it's in product or coding or testing or documentation or UX UI design. Which tools are going to be the right fit for different types of activities that we're doing? And then what are we starting to see in terms of the impact on the adoption and the frequency and intensity of that adoption over time? Constraints, and we're going to spend a lot of time today talking about the constraints, but constraints essentially are what is exposed by these AI tools, right? So if you don't systematically eliminate some of these barriers and these constraints within your SDLC today, you will definitely struggle to achieve any sort of material gain from AI. And then engineering impact. So how do we then start to think about the measure on productivity? Okay. And then finally, the results. So how do we start to have conversation with external stakeholders, whether it's in finance or product or the business more broadly, or even our customers? How is this adoption and use of AI and the transformation around the models, the architecture, everything that we're doing, how is that actually going to translate into some real discernible business benefit? And there's a number of different ways, different organizations think about that. So before we jump forward, I did want to mention that we do have a little bit of a survey that I'd love for folks to be able to start taking. So have we already launched the survey?
You'll need to launch it. I can't launch it on my end.
Thank you. I am doing it right now. Sorry, I was hiding in the little toolbar there, so apologies. So there's a few questions here. Please feel free to go through them on your own in the background, and I'll kind of carry on with the conversation today. So let's talk about rollout first. So rollout really is the key first step, and it's a very basic step, but it's a very important step because ultimately at the end of the day, you can't get results without adoption, but this adoption alone is not going to be enough. So you bought a bunch of tools. What do you need to measure? What do you need to be thinking about? So the key metrics that a lot of our customers are using today and focused on are very simple, quite frankly. One is the daily activity, daily active users. So what proportion of our teams are using these AI tools, not just on a weekly basis, but on a daily basis? And how does that then translate to our overall active license penetration? So we might have a few folks in our organization that are using it quite frequently, but are we seeing that consistently across the organization? Do we have a set of users that may not be using it very often? Is the investment that we're making in these licenses actually translating into adoption and usage within the organization? So very early days, very basic. Some of the intensity signals that you can take a look at is obviously your suggestions and your completions. For those folks that are using more agentic tools, the token use and token efficiency is quite important there. And then last is the trust. So, less so maybe on the agentic side, where acceptance rates or, acceptances aren't really part of the agentic model as such, but certainly in the generative, the Copilot side, where you're walking through and doing acceptances of what's being prompted by tools, shows a good level of trust, but also surveys, right? We would absolutely recommend that you have regular surveys across your engineering teams that are looking at core concepts of trust. To what extent do people trust these tools? Do they trust the responses? Why is it? And start to bring some qual input into this overall boom. So, enabling, you really want to get teams using multiple tools to start. I don't think that there's one size fits all. We certainly haven't seen one size fits all every organization. And I think a lot of organizations find their own path and what's going to be most meaningful for them. Obviously, focusing on hands-on training and clear data guidelines, right? Very, very important for teams to have some real good structure around the data itself that's going into these. From an Inspire side, so lead by example and empower AI champions. So, whether you're using Plandek and looking at through the lens of Plandek, or whether you have your own reports, try to identify who your power users are. Make them champions, share success stories. There is no stronger way of being able to build trust and adoption than people being able to look at peers and learn from peers and understand where they're getting success, what are the success stories, what are the unique ways of using these tools that will drive engagement further down. Next is approach. And I think it's important here, we don't have a particular position. There are certain tools that we use internally here at Plandek, which, have been tested through the same model that we covered before in terms of, deploying multiple tools and finding the right one for our environment and for our folks. But, there's no single best practice, right? You need to match the approach to the task. And so we kind of see it in four common patterns across our customers, right? So there's a traditional ask pattern, oftentimes conversational. So this is typically the way that you'd interact with ChatGPT. You might ask them about this, get a response, or hey, can you take a look, or they can correct this. Obviously, Gemini, Claude have these capabilities as well. You can do generating plans. So if you use plan mode in Claude Code or Windsurf, understanding a code base or generating Wikipedia or translating these things, or just inspiration, right? Playing around, trying to do a bit of discovery work and finding some unique ways to do something. Again, you have more of that ask dynamics. You're fundamentally asking LLM questions about tasks or topics or planning. The second pattern is assistant, right? So you think of this more of like a pair programmer, typically working within one of the IDE. So developer assistant specific tasks, or maybe more complex development tasks in the flow of coding. Those are quite common across really, whether it's Amazon Q, Windsurf, Cursor, Copilot. The far majority of organizations that we've interviewed historically on this point, the majority of their teams sit within the assist mode. So most organizations are still very much within that. Now, the leading organizations are really starting to move into the agent mode, particularly the autonomous agent. So the way that we differentiate the sort of agent supervised versus autonomous agent, agent supervised is really where you're working through more of a sequential or combination of broader tasks, still well-defined and typically still within a IDE. But this is kind of where your code writing takes place, your prototyping, and whether it's product teams using Cursor to generate prototype designs that, based on component libraries that then they work directly with customers or developers as part of that PDLC part of the process or discovery part of the process, or whether or not you're actually going out and building certain aspects of the application, but doing so by deploying multiple agents, but in a very kind of well-structured, well-defined, supervised way, right? So, you've got a human kind of telling the agent what to do, reviewing what the agent's doing, and then supporting that process. So it very much similarly represents the SLC of today. It's just you almost have an engineer deploying multiple agents as opposed to agents working relatively autonomously. Now, where we do see some organizations moving quite adventurously these days into the more autonomous agent. And by autonomous, what we're not talking about is people just deploying agents and letting them run in the wild. we're talking about is, deploying an agent in a way that it's listening to an ITSM incident management tool, right? And listening and watching for defects or incidents to come through, being able to spot them, identify them, read through, triage them, spot an area of the code base, and then open up a pull request for a developer to review, right? So they're not merging their own pull requests. They're not working fully autonomously, but essentially these are agents that are able to work within the context of software delivery, whether it's, listening to feedback that is coming from customers on certain product issues that they're having, looking at web analytics tools and being able to analyze them and see, okay, well, there's some friction on this part of the page. Maybe if we make this change, this will help. Or whether it's looking at incident management, we're seeing a few use cases popping up, certainly in which people are starting to productionize the use of these tools, whether it's Devin, Claude Code, Cursor, Klein as well. These tools are able to work in that capacity, the listening capacity for certain events, interpret, and then be able to propose something to a human developer, then be able to review and move forward. So those are kind of the four patterns that we see today. Certainly most folks are in the assistant mode. But the emerging trends certainly is for most organizations to continue to push the envelope on using autonomous agents for still well-defined tasks. And a lot of them are even reconfiguring what the team model looks like. And so whether that's you're working with one developer, one PO, and a number of different agents, we have a number of customers that are currently deploying that in multiple teams across the organization, or whether or not it's deploying these agents in full listening mode, in which they bring something back to the team to be able to review, and whether that's a PO reviewing certain requests for changes to the UI to make the customer experience more slick, or whether it's incident based. We see a few of those as well working. Now, kind of where you deploy these, and understand it. So the value-driven processes that we see these taken up, story refinement we talked about a lot. Really, when you think about how you're generating these stories, thinking a little bit about AI suitability, are these being written in a way, in a structure that's going to set our agents up for success? Having AI readiness checklists. So what are the things that we need to do to make sure that these are going to be in a good shape, ready for consumption of AI? I don't think that these are long-term checklists by any stretch of the imagination, but as we transition from a traditional mode into a new mode of operating, it's important to kind of think through what these checklists are and be able to kind of build new patterns of behavior with product teams, with engineers that adhere to these before it becomes sort of second nature. And then clear success criteria. And where we've seen a number of success pop up across, even within our business, but also with customers, is around test-driven development, right? So really leading in, almost re-energizing or bringing test-driven development back to the forefront in the way that AI can ultimately work through test-driven development models, understanding the sort of success criteria and what the end goal is before it actually starts to build something towards that. So it's a very effective model at doing that. Obviously, internal knowledge bases for AI reference, for the kind of technical foundations that you need to set. So this isn't, again, about just having documentation or code bases describing the code base. Obviously, that's important, but also implementing policies, security policies, government policies, governance policies rather, and component libraries in a structured way, in a referenceable way, so that not only can you bridge that gap very easily between product and engineering, but you give the AI a set of parameters and context with which to work, which will increase success rates of actually what it's producing. And then obviously being able to provide some security testing and observability guardrails as well around that as minimum. What we recommend, and we've seen this with a couple of clients already, and we'll give an example here of one. How do you test this, right? So what we do is you take, whether it's a simple project or a very large project, benchmarks that have been established. So if you worked 2 months or 3 months on a particular project, you know exactly how long it took you. If you could reapply that towards an agent, how long would it take? What would we learn from that process? So one of our customers recently had a 4-month project to enhance the sort of accessibility requirements of the website. Took them 4 months to work through everything in a traditional sort of product and engineering collaborative effort to define the requirements and make the changes, test the changes, deploy the changes. What they found is when they had after that was completed and they had their center of excellence team that was running some new agents take a crack at the exact same project, they were able to complete the project. Not only were they able to complete the code ready version of it within 1 day, but between all of the hardening activity to actually make it quote unquote production ready, even that only took them up to a week entirely. So they're able to collapse that down from 4 months to a week. So, it's definitely recommended to go out, take some known things, redo them in AI, redo them in agentic, learn from them, and also see what differences agentic AI can make within there. Take a quick breather there for a second. Let me just go to water. Now, I think the real focus of today's conversation is around constraints. Now, as we spoke about before, as you get better at task execution at certain parts of the SDLC, what you ultimately do, the code generation of itself may accelerate. There's been various reports that have reported anywhere between 20 and that 50% of that code generation acceleration or that task execution acceleration. The issue, of course, is what we call the bottleneck migration problem, which isn't that by adopting AI, it solves all of your problems, but it actually pinpoints certain problems. So your code review times significantly increase, your deployment process become overwhelmed, testing infrastructure can't keep up. The bottlenecks that you were seeking to alleviate, which was a human capacity problem before, in terms of being able to write code or copy and paste from Stack Overflow. But that whole activity of being able to do the code generation, yes, you might be able to speed that up, but the problem is that's only going to expose different bottlenecks in the process. So the individual productivity gains are ultimately absorbed then by the system level inefficiencies. And if there's one thing that I want everyone to take away today and really think about, it's that statement right there, that we might achieve productivity gains at an individual level, but those are immediately taken away if we don't have an efficient SDLC that allows us actually to deliver that stuff into production and keep in pace with what we're working on. So we've introduced, and this was very much inspired by one of our clients who really deployed this in earnest about 6 months ago within their organization and took a lot of inspiration from them on these points. And the way that we think about the constraint elimination process is really 4 key phases to it. So number one, identifying the constraints, right? So what are the quantitative signals and what are the qualitative signals? So if you're looking at increasing cycle time, breaking that down, what part of the process is increasing or why is it not decreasing? Being able to look at growing PR backlogs, where they're growing, why they're growing, at what stage of the process they're growing, deployment queues, test bottlenecks. These are all things that are indicating to you that you have systemic problems within the SDLC itself and constraints that need to be alleviated in order for you to actually realize the value of what AI can deliver. But equally is qualitative signals, right? So developers will express frustration. Again, having surveys that allow you to collect this information, process this information, and overlay it is really important. Retrospective things. So if you're seeing the same common themes that are coming from retrospectives, those are good qualitative indicators. And of course, stakeholder feedback, very key. Categorize them. So what are the different types of constraints that we tend to see? And we've listed 4 common examples. Obviously, feel free to categorize the ones for your own environment, but we typically see tooling level constraints. So what dependencies do we have, not necessarily in the AI tools, but in other tools that are presenting constraints? Code base or architectural constraints. Obviously, those are major ones, particularly if you don't have the benefit of working on a more modern architecture. You might find that there are some significant code base or architectural constraints that your teams are facing. Documentation, again, not just code base documentation, but policy documentation that allows AI to function more effectively with a context. The governance and security around that, training, and ultimately the culture, right, which really brings to the forefront people. And I think culture is certainly one of those things that in all of the surveys and all the conversations that we've had, typically tooling, code base, and culture and workflow tend to be the 4 biggest ones that people find different constraints. Then addressing them. So how do you address them? So you identify these constraints, systematically documenting, and then whether it's creating a dashboard in Plandek or in other areas, being able to understand where do our constraints sit, in what categories, and then being able to prioritize, work on multiple ones in parallel, think about prioritizing based on the highest impact. And I think really importantly, thinking about how are we socializing this with stakeholders, because the systemic constraints are the things that are least understood and least talked about, but they're actually the biggest impact in why teams struggle to translate AI usage into actually delivering value or deriving value from that AI usage. So the more that stakeholders, whether it's the board or CFOs or whatever, the more the other additional stakeholders are aware of these, where they understand the actual constraints that sit within the system that are prohibiting it, but more importantly, we know these, we're acknowledging them, we're doing something about them, and we're able to systematically burn them down. And then repeating. So relentlessly and obsessively thinking about this as a continuous improvement cycle, evaluating the metrics, constantly going back to quantitative signals, going back to qualitative signals, pivoting when you need to, and just constantly going through and repeating this process over and over again, because it's unfortunately, it's not as nice and neat as just having an initial set of constraints. You get rid of those and everything's fine. Every time you alleviate a constraint, obviously there's a risk of another constraint materializing or at least becoming more evident. And so it's by nature needs to be continuous. It needs to be cyclical and fun. Going through kind of the 7 common categories already. So I won't spend a load of time here because we kind of went through each one of these, went through in the previous slide, but obviously, do you have the right tooling? Is code structure, limit parallelization or automation? AI tools and human, do they have the context that they need to succeed? Workflow and process, governance and compliance, training, it kind of goes without saying, and culture. So not only leadership buy-in, but also culture within the teams themselves. Naturally, different people are going to think about AI in very different ways, and so it's important to identify and address these proactively as a leadership team. So the teams that typically succeed, the ones that measure baseline constraints before adoption, right? So if you already are very well familiar with your SDLC, the constraints that you're facing, you're already kind of one step ahead of the game. You know what you all already need to fix or improve before actually adding a catalyst like AI into it. Anticipating where new bottlenecks will emerge. And I think this is really important. By doing this process over and over again, you train those muscles to really get teams or enable teams to start to think in an anticipatory perspective where new bottlenecks. So if we alleviate this and we alleviate this, what's going to happen next that will probably expose this? And so getting them to think a little bit in advance. Proactively investing in those areas. So really, whether it's a tooling constraint or whether it's workflow constraint, being proactive and investing in the alleviation of some of those constraints, and then seeing individual gains actually translate into organizational outcomes, right? So we start to adopt it. We start to do this within the SDLC. We can see actually how those individual gains are materializing into a better cycle time, a better lead time to value. That's what would also that's what ultimately gives you confidence that there are no constraints or a minimal amount of constraints that are materially slowing you down. Teams that struggle tend to focus only on AI adoption. They'll naturally be a bit surprised when the metrics don't move. Hey, we're using it. We've got loads of acceptances this month. Why aren't we delivering faster? Seeing individual gains absorbed by inefficiencies is obviously naturally a big reason for that. And again, this is a little bit of a generalization, but ultimately teams that tend to sit there and just point fingers at the tool rather than actually thinking about the constraints systemically are almost setting themselves up to fail because they're kind of looking at the wrong point. They're looking at the tool itself and not at the overall SDLC and the things that are really slowing down. So, this is really for us where, everything in RACER comes together because it's where rollout then starts to really materialize into results for your team. The next part of the engineering impact. So I won't spend a load of time on this because I know we've covered it previously, but whether you pick the 4 pillars of productivity, which obviously we very strongly subscribe to, and there's a industry-wide benchmarks behind these, but regardless of what you pick, establishing a core set of measures for productivity, ultimately looking at the quality side, the predictability side, the speed side, and really how does that translate into increased capacity to focus on the things that matter, because that's really, really, really going to be the one important thing to being able to enable you to show results in some of those more business-oriented KPIs, whether it's revenue or engagement stats or NPS stats. That's what's really going to make a huge difference. So what to look for in your metrics? Obviously, positive signals, cycle time decreasing, even as sort of PR volume increases. So you're going to see a lot more PRs coming through. But ultimately, our cycle time as a whole is decreasing because we've alleviated a lot of those constraints that have been slowing us down before. Sprint predictability improving, and this is actually probably the number one thing. So most of the teams that we've analyzed, the one area that does tend to improve first is predictability. So this is a good leading indicator that you're on the right direction. Speed, unfortunately, is probably the slowest one, and that's because speed covers a complex set of issues, a complex set of constraints, and so it's not as easy as just alleviating 2 or 3 of them and everything's fine. It typically needs more systematic probe. Planned work percentage increasing. So again, the work that we've got planned, the roadmap work, the technical debt work, increase capacity against that, technical debt stabilizing or decreasing. So what you have in your backlogs, of course, is able to decrease. Warning signs, individual productivity up, but organizational throughput flat, kind of goes without saying. PR backlogs just growing and growing and growing. It means you're not keeping up with it. Testing time increasing and deployment frequency flat. So those are four kind of key areas where you think about, end-to-end delivery process. You can really identify very quickly in the PR side, the testing time, the deployment time, what's queuing up for engineers. Very, very good indicators of where there are constraints appearing or things that are constraints that are slowing you down at each step of that process. Now, lastly is the results. Now, before I jump into this, I guess I'll offer one caveat. I appreciate there's no one size fits all for the results. We as a business, growing business, we are definitely looking to use AI constantly as a way of innovating and accelerating what we can deliver and improve the quality of what we're delivering to our customers. Some organizations appreciate that might be a different stage of the product life cycle or the business life cycle where it may not necessarily only be about accelerating delivery. There might be some cost rationalization, cost reduction parts of this business case as well. So this is not meant to be a one size fits all, but a conceptual way to start to think about how do you start to think about the ROI formula. So what you'll see here is, ROI is revenue acceleration plus cost avoidance and reduction over the total cost of tooling. And so revenue acceleration is exactly, to what extent are we able to deliver more of our roadmap faster, reduce our cost of experimentation. We found, for our own purposes, that lead time to value is a very, very good measure for this. But we definitely recommend that you work with your finance teams to how do we translate that into revenue benefits, okay? Cost avoidance and reduction. So, without constraints elimination, without constraint elimination, naturally, this will be absorbed by bottlenecks. If you start to alleviate those constraints, you'll be able to redirect that team towards higher value work, for instance, the roadmap. So starting to think about, obviously avoidance in terms of what capacity you have to allocate for additional capacity needs to be allocated to achieve that roadmap versus by eliminating the constraints, you redirect that. So it's a, cost avoidance in that kind of direction. Obviously cost reduction, I think is a pretty straightforward. So think about in terms of, the different patterns of time savings, but ultimately that time savings is only valuable to the business if it's redirected strategically. So redirected towards things that are of strategic importance, whether that's roadmap, it might even be technical debt in a particular quarter or a particular phase of a product. But a lot of this will require process redesign and not just the adoption itself. So think a lot about how that process redesign is going to enable you to actually achieve those. And then the total cost of tooling, obviously licensing and usage of those tools. So some of it's just a pure license plays. Some of them you're buying tokens and utilizing tokens or some comparable notion of that. So think about the licensing and the usage, obviously the implementation, the management, any sort of security, governance or compliance costs on top of that are introduced by AI, because there will definitely be a few. And then constraint elimination. I think it's really important. It's easy to forget this because you can really maximize the ROI. But if we're being honest with ourselves, constraint elimination is part of the actual investment you need to make. It is essential to you being able to achieve success. So therefore it needs to be included as part of the total cost of tooling. So think about whatever you're making in terms of constraint alleviation, if that has a cost impact, really it should be considered as part of your ROI formula, at least the way that you think and conceive of these things. So a little bit of a wrap up and kind of next steps, and then I'll hand over for some questions. I love this statement from the State of DevOps from last year. The AI doesn't create organizational excellence. It amplifies what already exists. And I love that because it is so true. The value of AI will be unlocked by reimagining the system of work and habits. I think that's a really nice way to think about, to self-reflect on your own teams, your own tooling, your own workflows, your constraints that you have today. AI is not going to resolve most of those. It's just going to amplify it. Okay. So it's a systems tool and not a problem tool fundamentally, right? Measurement is really foundational, especially in the constraints. So being able to measure at every stage of RACER is critical, but particularly when you start to look at the constraints. Obviously, balance is really good. So not just overly focusing on speed and just trying to get as quick as possible at the consequence of quality issues or predictability issues, but having a balanced measure across 4 pillars that we offer, I think is a really good balance for you to start to think about those things. The perception gaps is real. So developers may feel that they're faster while the metrics stay flat. In fact, I think the perception gap extends beyond that because it's not even a sort of what developers feel. It's also aligns with expectation. The expectations is that we'll do much faster, will actually the metrics stay flat. So that is really important to focus on. And again, just to reiterate, the constraints are the ultimate unlock. There are individual gains without constraint elimination will never translate to any sort of meaningful organizational value, ultimately or sustainably for your business. So next steps this week, what do I do? So first thing, start to map your current constraints. What are the bottlenecks that you see in your SDLC? Identify the top 3 using the 7 categories, and establish a baseline metrics for your 4 pillars. So on the right-hand side, just look through your cycle time, look through your lead time to value, have a conversation, and really challenge yourselves on what part of this process is reflective of the fact that there might be constraints that are sitting within it. Okay, you can see quite a spiky example here. Definitely some areas to look at in terms of constraint theory and understanding what's actually driving some of those queuing states, and identifying the top 3 using the sort of categories and thinking about which of these have the biggest impact. I think the general point to ask yourselves as well is, are you starting to see individual gains without organizational improvement? So do you see lots of engineers reporting that, hey, this is great, I'm getting this through so much faster, and then you step back and look at what the team is doing, they're not actually delivering that much faster, right? That's a really good indication that there's something else going on just outside a developer using a tool, and you need to be mindful of that. Next 30 days, think about creating constraints dashboard. We have a number of clients today that they track the stuff, the data, and present it into Plandek. Very easy for you to take a look at it by tool, take a look at it by constraint type or by category. Really start to understand what is the rate of creation, how much are we alleviating these, what is our backlog, how are these distributed across different tools. If we find that actually our biggest Cursor provides more constraints than Devin does, maybe we should be pivoting and investing more in Devin right now than Cursor. I'm sorry if there's any Cursor people on the call. It was just an example. And then thinking about that productivity framework, I definitely would think about a balanced scorecard that covers all 4 pillars. But if you want to just cherry pick certain ones that are meaningful to your business, that's absolutely fine. I think getting started is the most point, rather than trying to be perfect from the start. And then next quarter, thinking about launching a systemic constraint elimination program. And that sounds quite cumbersome there, but I think what it really means is committing yourselves to tracking, reviewing, discussing, reiterating, going through that continuous improvement loop in a very serious way, not just in the teams, but across teams and organizationally, really kind of building that into your culture. Starting to implement the full RACER measurements. So understanding how do we measure these at each stage, I think is really important. Start tracking ROI with finance. So again, the earlier you can start those conversations and get on the same page, the better. Building quality internal platforms to amplify those benefits is really important as well. And then measuring constraint elimination impact on engineering metrics, right? So you can start to see that correlate between who's using it, how frequently using it, what impact is that ultimately having on our different metrics within the 4 pillars. So thank you, everyone. Obviously, we have time for questions now, so I'll go through, but just there is a full guide available on the website. So I figured I'd throw this today. If you've got your phone sitting with you, you can zap the QR code and start to download the written version of the guide. Pretty much I've covered everything that's in there, but there's a lot more use cases, a lot more conversation about these things that goes into kind of a deeper level than we were able to do today. So let me go to the Q&A. Give me half a second here. So first question is Sergey's question here. So any suggestions, ideas why predictability is improving and the plan work percentage is increasing? So predictability, I speculate a little bit here because it's a little bit difficult, but the reason I think that predictability has been the first area to be positively impacted is because one of the things that AI can do is reduce complexity and risk in some complex tasks. And so what that means is teams will tend to plan for the same amount, but utilize these tools in a way that reduces the risk, which actually gives them some borrowed capacity. And so what they're actually able to deliver within a sprint is enhanced from a task execution perspective for a particular, so it's less about the overall flow and more about, we're going to start here, we're going to finish here. Can we get through that subset of the process on a much more consistent basis within a sprint? I think AI is starting to have that impact very directly for teams in that particular area. Now, ultimately, how does that, you know, how did, let me see the other part. Any suggestions, idea on planned work percentage is increasing. So it's a combination of the things. Obviously, as you start to work more efficiently within a system, as you give yourself the benefit of being able to address and alleviate bugs faster so that it costs less time per bug that you fix than one that you would put in a backlog, you gain that time back. And that time naturally is going to be driven or should be driven by the next most important thing, which should be, I think, more broad. Like generally speaking, it's going to be value delivery for our customers and for new business, increasing our revenues, protecting our revenues. Now, there are going to be teams that are working on technical debt initiatives, strategic technical debt, and that's absolutely fine as well. The point being is what you're doing is starting to alleviate and reduce the amount of time spent in that unplanned area, and that's reducing that inefficiency. And that's going to give you more time to spend on the things that you want to spend, probably most of the time roadmap, but also giving you more time to focus on technical debt as well. And then Ramsey asks another question, which is, aside from being aware of the process constraints before adopting AI, do you see any other patterns in the companies that are getting good success with autonomous agents versus those that struggle? So, for example, the size of the company, the type of product, et cetera. So it's a great question. And I think where I would start is, I think the organizations that we see making the fastest bit of progress, I think have two things in common that I've seen. One is a obsessive level of confidence that this is the direction that they're heading, right? So it's less about, should we do this, should we not, what do people think, and so on. It's the world is moving on, and the companies and the products that survive are the ones that are going to drive this journey. And the ones that have taken that sort of mentality and have been unafraid of changing how they work, experimenting, changing the operating models of teams are the ones that have had the best success. Now, I appreciate that's not a one size fits all for some organizations, right? Some organizations aren't that big. I don't have a hard number for it, but say if you're an organization of, 50 developers, you don't have the luxury of capacity to be able to truly innovate on the side, right? And so what we tend to see at the larger organizations, and I don't mean thousands or hundreds of engineers, just a bit larger than that, are the ones that are able to carve out a little bit of space on the side for innovation, but then very quickly move that into change across the business. So change across with the technology teams themselves. Obviously, more modern applications tend to lend themselves for obvious reasons, because you think about the system of theory of constraints and systemic constraints. With modern architectures, you obviously, they have fewer constraints as a whole, but also they're a little bit easier to address, particularly code-based and architecture ones. So, but that's not always the case. And a lot of these tools are being used to modernize these applications and alleviate some of those constraints as well. And then faith, sorry, is ask question. It's a long question, so give me half a sec to read it. If we expect that an increase in implementation and unit testing leads to a higher number of pull requests, developers may spend less time on individual tickets because they're working in smaller, more incremental changes. However, this also increases time regarding code reviews. How should we manage ticket ownership in the scenario? Right. I think I get the question. So essentially what you're saying is, as we shift, that is, I think, resulting in a higher proliferation of code changes, code reviews, which is going to then consume a higher proportion of time. How do we balance these things between reviewing and actually working on new work? So I think this is where really a lot of the customers that we work with today are getting a lot of value from the agentic side, because kind of the pattern that you're talking about here is sort of operating within the same model where we haven't really changed how we're working. We're just changing who's doing what within that same process. And so it's a shift from being able to work on new things because we've got to manually review the old things. So working with the new things, the agentic model allows you to basically task out agents in a much more effective way to actually start getting that work done. There are tools out there. CodeRabbit, I know, is one of them that's been used by some of our clients, where they'll actually have CodeRabbit working alongside an agent, and let's say Cursor in CodeRabbit, or Devin in CodeRabbit, or Claude in CodeRabbit. Once that pull request opens, basically the two work together, and the human, engineer can sit there and actually review and walk through that conversation, see what's changing, what's tweaking, how complexity is being erased, dependencies are being raised, how they're being alleviated. So it actually speeds up a little bit of that pull request process. I think that's still a little bit of its infancy, and I'd be lying if I say I've been really sat alongside those teams working through it and how they're doing it. But I know that doesn't quite answer your question. So how do you manage ticket ownership in this scenario? But I think the way that a lot of teams that are achieving success are doing so is when product doesn't create tickets, they create prototypes. Those prototypes are based on component libraries, policies that an engineer can take up and put into that point, overlay agents, actually work through and iterate that into a production level. So I think in some ways it starts to kind of one step earlier, rather than just having a whole sequence of tickets that we're handing over, starting to think about how do we simplify the tickets and actually put more time and focus into the components, into the prototypes rather, the prototypes that actually are ready to be transitioned into a developer, where they're built on a shared set of component libraries, policies, etc., which then adds better context for the AI, so it can then start into agentic mode more effectively. Jade. Who? How long have you seen it takes on average to go from individual productivity gains in specific areas to successfully removing system level constraints? So I don't have a timeline for that. I think it depends on the nature of the constraints and the amount of constraints. There's some constraints which are simply quite basic, and you can alleviate them very quickly. So if teams are tracking them, alleviating them, and you have a good continuous cycle around that, it's very easy. Some of them are more complex. So if our biggest, let's say for instance, let's say we deploy once a month, okay, that is going to be a huge systemic constraint for us. And it's not just as easy as saying, well, let's just deploy more frequently. There are a number of things that need to fit into that. So how that breaks down is very much going to be unique. So I don't have a time for you, but I think you'll find as you go through it, there are going to be some really high impact, important constraints that are going to take a long time. Some that'll take a very short period of time. I also think at the same time, it's a lot of the teams find that it's a bit of a whack-a-mole process as well. Identifying constraints, alleviate them, identifying the next one, alleviate them. Let's come back. How can we balance the need for short-term fast delivery with maintaining the long-term health and maintainability of a project? Specifically, how should we handle situations where short-term gains like quick features or rushed fixes might create technical debt or long-term problems? So I think this is where something like a center of excellence or an innovation group works quite well, because what you're able to do is test out the new models and how to get them to work without impacting the short-term deliverables that you have. So keeping teams focused on what they need to continue to deliver and their commitments right now, and having a different team actually start to understand what does this new way of working look like, and then transitioning teams from one into another. That's the pattern that we've seen work quite effectively. So if I think of the organizations where our customers, where there's really quite a significant agentic presence and where they're working in really different operating models than they've historically done, that's how they've done it. They've started very small. They haven't tried to figure out everything. It's used the sort of Mark Zuckerberg, move fast and break things method. And then more and more, they brought more teams into that model, more teams into that paradigm, more teams into that paradigm. Creating, I think that kind of answers the question, because I think as a result of that, you minimize the amount of technical debt and long-term problems that you create if you've got obviously the right people that are working after it. Right. So I think that takes us to the end, I believe. What time is it? Yes, it does. So thank you very much for us today. Obviously, my email is here. So anyone who asks a question or didn't get a chance to ask a question, please feel free to reach out, download the guide as well if you get a chance. And thank you everyone for attending today, and have a lovely week, and we'll speak soon.